begin. All right. So we spent less time in graphed sine and cosine. That's not the only. Those aren't the only trig functions. There's also tangent, secant, cotangent, and cosecant to worry about. But if you know what sine and cosine do, then you can probably figure out what tangent, secant, what the other trig functions do, because they're just like fractions involving sine and cosine. Let's use this to do exactly that. Let's identify which of these is tangent, which of these is cotangent, which of these is cosecant, which of these is secant. And we'll do some stuff below to figure that out, but maybe I'll just see if anyone has any intuition right now. Anyone want one of those graphs to be one of those functions? Yeah.
Tangents top left, cotangents top right.
I feel like I'll use erasable pens. I think that's right, but let's see. Maybe this is tangent. Maybe this is cotangent. Why? Oh, okay. Let's try to be convincing about it then. Looking at those two things, here's something you can read off from those graphs. You can tell by just looking at them where the vertical asymptotes and x-intercepts are, right? We can also detect vertical asymptotes and x-intercepts of tangent and cotangent. Let's do that. Tangent is sine over cosine. This is a fraction. It's easy to detect when a fraction is 0, the numerator has to be 0. So if you want to detect an x-intercept, well, that means you want to know when is the numerator equal to 0. Oh, God damn it, Chris. It's off screen. So tell me, when is sine of x equal to 0? And there are two good ways to see this. Have we graphed sine of x already? Oh, well, we could read it off from the graph of sine of x. We could also read it off from a unit circle. Let's maybe even do both and see if they give consistent results. There's the graph of sine of x. Where does it appear to have x-intercepts? I guess just list the first few of them. 0, pi, also negative pi. If I kept going, do you think there would be 1 at 2 pi? Negative 2 pi? 3 pi? Any multiple of pi? All right. Any multiple of pi. Let's also see that by looking at the unit circle. So sine of 0 is 0, so there's an x-intercept at 0. Sine of pi is 0. 2 pi, sine is 0. 3 pi, 4 pi, 5 pi, yeah, any multiple of pi. So if this one is allegedly tangent, let's just see if we believe that. Does that graph seem to have an x-intercept every multiple of pi? Cool. That seems pretty convincing then, doesn't it? Vertical asymptotes. Can you also tell where the vertical asymptotes are by looking at that graph? I think so. Let's see if this gives the right answer. So to detect vertical asymptotes, well, you set the denominator equal to 0. So play the same game. Either look at the unit circle, or pull up, or look at a graph of cosine. Tell me, when is cosine equal to 0? And I guess you can just start listing them if you like. Pi over 2. Anywhere else? Negative pi over 2. Anywhere else? 3 pi over 2. Is there a pattern there? So it looks like any odd number times pi over 2. any odd multiple of pi over 2 appears to be a vertical asymptote. Let's see if that agrees. Does tangent have a vertical asymptote at pi over 2? And 3 pi over 2? And I guess that's as far as this picture of the graph goes. Negative pi over 2? Negative 3 pi over 2? Cool, yeah. I think that this is, in fact, y equals tangent of x. And if that's tangent, then surely cotangent looks an awful lot like tangent because, like, instead of sine over cosine, it's cosine over sine. So it's got to be, like, similar looking. So I think I believe it. Let's check asymptotes and intercepts. Cotangent. If I want the x-intercepts, what should I set equal to 0? The numerator? Right, whenever you have a fraction, that fraction is 0 when the top of the fraction is 0. Oh, cool. Have we in fact already found when cosine of x is equal to 0? Yeah, it's like 3 lines above. Any odd multiple of pi over 2. Is this graph consistent with that sentence? That's good. All right. How about vertical asymptotes? What should I set equal to 0 to get vertical asymptotes of tangent? Nope, cotangent. Sine of x. Oh, have I already written down when sine of x is 0? Any multiple of pi? Is the graph labeled as cotangent with a question mark consistent with that? Cool. I think I believe it. There's the graph of cotangent of x. All right, that leaves 2 other candidates. I guess one of them is secant and the other one is cosecant. Any guesses as to which one should be which? Well, let's try to figure it out. Let's check for vertical asymptotes because both of these suckers seem to have some vertical asymptotes. Secant is 1 over cosine. So if you want to find vertical asymptotes, when does it have a vertical asymptote? When the denominator is 0? Oh, when is cosine of x equal to 0? The sentence written directly above? Okay, cool. Which of those 2 things has a vertical asymptote every odd multiple of pi over 2? Oh, cool. So I guess, assuming that at least one of those 2 things is the graph of secant, it has to be that one? So I guess the other one must be the graph of cosecant x, unless I've like done something really silly, not actually given you the graph of cosecant in this list. Let's check vertical asymptotes anyway. How do you find vertical asymptotes for cosecant? So denominator equal to 0. And maybe I won't write anything. So when is sine of x equal to 0? Every multiple of pi, as is written already, like at least 3 times on this, twice on this page already. Every multiple of pi. Does this have a vertical asymptote every multiple of pi? Sure seems to, at least the first 5 of them, depending on how you count. Nice. So yeah, I think that one is in fact the graph of cosecant x as it's labeled. People feel okay about that? Nice. So, with that out of the way, I would like to start developing some properties of trig functions that come from the following. So trig functions come from the unit circle. The unit circle is a circle. It is like the most symmetric thing. So is there something that I can detect out of trig functions that corresponds to, I don't know, reflecting 180 degrees? Probably. Let's just try to figure out what that is. So what I am going to try to do with today is fill in this table with identities. And I think I want to get this filled in, and then we'll start thinking about like how to get these using like the geometry of the unit circle and like right triangles and stuff. But for now, let's look at a graph to try to read these off. Here's the graph of cosine of x plus 2 pi. What would you say that graph looks like? Maybe it would help to have the graph of sine and cosine still hold up. There's the graph of cosine of x and sine of x. There's the graph of cosine of x plus 2 pi. Which of these two graphs does that one look like? Cosine of x. So that's something that suggests that cosine of x plus 2 pi is the same thing as the cosine of x. How about the cosine of x plus 4 pi directly below it? What does that graph look like? Still cosine of x. And now I'm going to jump to the next column over. Sine of x plus 2 pi, sine of x plus 4 pi. What do those two graphs look like? Just sine of x? Oh, so there's nothing new there. What's the period of cosine and sine? 2 pi. This is exactly what the period means. The period means that when you add 2 pi to an input, you don't change the output. So yeah, this isn't new. Those two you already knew. Cosine of x plus a multiple of 2 pi is the same thing as cosine of that same input, which in this table I'm labeling it as theta because I want to think of it as like an angle of rotation throughout this packet. But when you're graphing something, the input is x. So you'll have to excuse the change in variable names between the bottom half of this page and the top. There's nothing drawn here for cosine and sine, but let's just stare at that for a second. That looks like the type of thing you would check for even and odd. Oh, well, let's see. Cosine, is that even or odd? Possibly by looking at the graph of cosine on the bottom half of this page. Cosine is even or odd? Even? Odd? Neither? Confused about how to determine. Yeah, let's determine. So there's the graph of cosine. To be even, it should be symmetric across the y-axis. So as you go this way, if you want to take that and reflect it over the x-axis, would you get the other half of the graph of cosine? So it's even. It's even. Since it's even, what can you do with that negative sign inside of the parentheses? You could just forget about it. Erase it. Cosine of negative an angle is the same as cosine of that angle. Same questions for sine. Is sine even or odd? Sine is even. Sine is odd. Okay, good, that's more hands. Unclear, and I should discuss how to detect even and odd? Yeah, let's talk about how to detect even and odd. So here's what I'll do. There's the graph of sine of x. I'm going to take the graph of sine of x. I will pin down the origin and rotate it 180 degrees. Does this graph still look exactly like the graph of sine of x? Yeah, so it's odd. Alternately, if you take a point on the graph of sine and reflect it over the origin, you still get a point on the graph of sine, so it's odd. All right, so since sine of x is odd, what can you tell me about a negative sign inside of the parentheses? You can't just erase it, but you can pull it out front. Cool. Let's think about the remaining lines. There, in that line, underlined with my pen, are the graphs of cosine of pi minus x and sine of pi minus x. Look at cosine of pi minus x for us. There's the graph of cosine of pi minus x. What would you say that looks like in terms of either the graph of cosine or the graph of sine? It looks something a lot like cosine, but it's not quite cosine. What's it off by? Flipped. So I think it's negative cosine of x. Cosine of x plus pi is the same as negative cosine of x. Sorry, pi minus x. Sine of pi minus x. So there's the graph of sine of pi minus x right there. What would you say that looks like? Just sine of x. So sine of pi minus theta, same as the sine of theta. In the next row, you see pi plus an input. So I guess in some sense, those things are just cosine and sine, but shifted left by pi over 2. Tell me about those graphs. What do they look like? And I guess cosine first. Cosine of pi plus x, that graph looks like, yeah, it looks like it's just become negative. And what about sine? Yeah. Negative sine x. Excellent. So when you add pi to an angle, sine and cosine both become negative. Pi over 2. So the next row in the table is pi over 2 minus an angle. So tell me about cosine of pi over 2 minus an angle. What would you tell me that that looks like? Sine. And what about sine of pi over 2 minus an angle? Cosine? Oh, when you replace an angle by pi over 2 minus that angle, apparently sine and cosine just swap. Cosine of pi over 2 minus x is sine x. Sine of pi over 2 minus x looks like cosine x. Cosine becomes sine. Sine becomes cosine. All right. Same thing, but replace that plus by a minus. Are you on negative sign? I'm not looking at the graph. Does that agree with what you think? Okay, same thing, but what about the next one over? What about sine of pi over 2 plus x? Just cosine? No negative at all? All right. So when you add pi over 2 to an angle, sine becomes cosine. Cosine becomes negative sine. Cool. All right. So we have those things written down, and that was just by looking at a graph. Let's also try to explore those things by thinking about unit-circle stuff. And I think the first one is the easiest to explain, that first entry in the table. So let's start there. And I might not even write a whole lot. So let's think about what happens when you add 2 pi to an angle. How big an angle is 2 pi? It's like a full revolution. 360 degrees if you like degrees, but I think what matters is its full revolution. So if you rotate forward by an angle, or you rotate forward by an angle, and then an extra full revolution, do you end up at the same spot? Oh, trig functions are just determined by the spot you land. So extra full revolutions don't affect trig functions. That's all this says. So cosine of theta plus some full revolutions is just the cosine of theta. Same thing with sine. Same thing with secant. Same thing with cosecant. Same thing with tangent. Same thing with cotangent. Easy enough. And hopefully also pretty obvious. So maybe I'll even add something to the table on the previous page about why these things are true. So, why are these two things true? They're true because full revolutions don't matter to trig functions. Right? And they don't. That's all that first row says. All right. So let's think about negative angles. Let's think about those in terms of unit circle stuff. So let's think about what a negative angle means. So if you start, I'm going to do an awful lot of this today. So if you start with some angle theta, so you're rotating up by some angle theta, then rotating by negative theta just means you rotate down. So let's rotate by theta and negative theta. The trig functions are determined by the coordinates of my fingertips. How do the coordinates of my fingertips compare? X coordinates first. How do the x coordinates at my fingertips compare? They should be the same if I've done this correctly. How do their y coordinates compare? They're the same but negative of each other. So, oh, that tells you everything about trig functions, doesn't it? Cosine is the x coordinate, so it stays the same. So if there's an angle theta, pictorially anyway, there's an angle of negative theta. X coordinate stays the same, y coordinate becomes negative. Cosine is the x coordinate, so cosine of negative theta is the cosine of theta. X coordinate stays the same. Sine of negative theta becomes minus sine theta. And that hopefully agrees on the nose with what is in that table on the previous page. So why is that row true? On the one hand, it's because sine is odd and cosine is even. But on the other hand, it's also because negative theta corresponds to a reflection over the x-axis. If you take an angle theta and replace it by negative theta, then you're doing this. You're reflecting over the x-axis. That seem pretty good? All right. Do you think many of the rest of these will correspond to similar, I'm pointing in two different directions, tell me how they differ? Yeah, that's what a lot of this will be. Maybe before doing that, let's try to think about secant, cosecant, tangent, and cotangent at negative theta. And let's not try to do it like from scratch. Let's do it using sine and cosine. And maybe we'll do like secant and tangent together, and then I'll write some stuff about cosecant and cotangent. What is secant? Say louder.
1 over sine.
No, 1 over cosine.
Oh, cosine.
Yeah, right, it's confusing because of reasons that I certainly haven't addressed. Secant corresponds to cosine, cosecant corresponds to sine. And that's an annoying truth that you just kind of have to deal with in your memory. So secant of negative theta is the same thing as 1 over cosine of negative theta. Oh, but do I already know what cosine of negative theta is? What can I do with that negative sign? Just drop it. Cosine doesn't care about it. Oh, but what is 1 over cosine of theta? Secant? So secant of negative theta is secant of theta. And I guess that's not so shocking. Secant is just 1 over cosine. Cosine didn't change, so secant won't change. Let's also do tangent, and then for the sake of time, I'll put the things in this column. Tangent of negative theta. Tangent should be one that you do remember more quickly. Tangent is what in terms of sine and cosine? Sine over cosine. All right, it should be, if it's the slope, it'll be y divided by x. So it should be sine divided by cosine. Tangent of negative theta is sine of negative theta divided by cosine of negative theta. Oh, but do I know what I should do with each of those negative signs in those parentheses? Oh, I'm sorry. Yeah. So I see sine of negative theta. What is sine of negative theta? Negative sine of theta? What about cosine of negative theta? What can I do with the denominator of this thing? It's just cosine of theta. Oh, now that I've done that, is that something you recognize? What is that? Well, it's negative, so let's just stick the negative there. Sine over cosine. What is sine over cosine? Tangent. Tangent of negative theta is negative tangent theta. Do you think you could do something similar to get cosecant and cotangent? And maybe we'll talk through and do it intuitively. So cosecant is 1 over sine. What does sine do when you stick a negative inside of it? That negative sign will pull out? Oh, so you'll wind up with like a negative in the denominator. If the denominator is negative, you can just make the whole fraction negative. Cosecant of negative theta is negative cosecant theta. How about cotangent? Let's maybe like imagine what would happen while pointing here. So cotangent of negative theta would become cosine over sine. Let's see, cosine would stay the same, sine would become negative. Oh, is that still just negative cotangent? Awesome. So here's, I think, the big takeaway. You don't need to remember those. Those are not things you need to have memorized. Because if you know what happens for sine and cosine, you can reinvent those reasonably quickly. Nice. So, carrying on, I have 10 minutes left. I think I can get some of what I want done. Let's think about pi minus theta and pi plus theta. And maybe we'll even do them both at kind of the same time. So, how big an angle is pi? Half a revolution. It's 180 degrees if you like degrees. So, let's start at this. So, in order to think about pi minus theta, let's start by rotating forward by pi. So there's an angle of pi and an awful lot of shoulder pops. Was that audible in the audience or just to me? Okay, that's probably great. So here's an angle of pi, here's an angle of 0. As I rotate up, this one will rotate by theta. I want to move in the negative direction from this angle. So I'll rotate this back by theta while I rotate my left hand up by theta. How do my fingertips compare? How do the x coordinates compare? I saw like this, but I want someone to say something. Same number, but this one has a negative x coordinate. So, drawing that, if there's an angle of theta, then there's an angle of pi minus theta. It looks like x gets negated. What about y? Sorry, I take the pose again. Y values stay the same? All right. Does that tell you how sine and cosine change at least? Yeah. How does cosine change? It becomes negative. Cosine of pi minus theta is negative cosine theta. Sine of pi minus theta is sine of theta. Sine is the y coordinate. The y coordinate didn't change. Oh, does that now also tell you what secant, cosecant, tangent, and cotangent do? Yeah. Maybe, well, let's see. I think we can do secant and cosecant basically without writing anything. Secant is 1 over cosine. So if cosine becomes negative, then what should secant do? Also become negative? Because it'll just be like the denominator gets negatived. Cosecant. If sine stays the same, then what should cosecant do? Stay the same. Tangent and cotangent. So tangent is sine over cosine. Cosine becomes negative, sine stays the same. So what should tangent do? I think it'll become negative in total. People buy that? Should I write anything for that? All right, then I will write something for that. So if you want to think about tangent of theta, well, tangent is sine theta over cosine theta. So if I want in particular to think about tangent of, oh, there's not enough space. Tangent of pi minus theta, that means I want to think about sine of pi minus theta divided by cosine of pi minus theta. But I know what sine of pi minus theta is. It's just sine of theta. Equals sine theta. I know what cosine of pi minus theta is. It is negative cosine of theta. Just need to throw that n away. Fair enough. Oh, so I see a negative in the denominator. When the denominator is negative, you can just make the whole damn fraction negative. I now see sine over cosine. That's tangent. Think analysis for cotangent will be similar? Yeah. All right, angle of pi plus theta. So I'm going to make the same, like, hand gestures, right? There's an angle of 0. Pi is half of our revolution. Now I want to rotate both of them in the positive direction. I want to rotate this one by theta, this one by theta. So I'm rotating both counterclockwise. So doing that, that's where I end up. Tell me about how my xy coordinates compare. both opposite. And maybe I'll make one more observation for the sake of tangent. Tangent is the slope of these lines. How do the slopes of my two arms compare right now? They're the same, so I think tangent will stay the same. That's kind of neat. So let's write that down. So drawing a picture, there's an angle of pi plus theta, since pi equals 1/2 of a revolution. Both x and y become negative. I don't like become negative. If they were negative already, they would become positive. So that tells me a lot. Cosine is the x-coordinate. Cosine of pi plus theta is negative cosine theta. Sine of pi plus theta is negative sine theta. Tangent is the slope, so I think I'm already convinced that tangent of pi plus theta is tangent of theta. Yes, yes I can. I hope. Yes, it appears I was able to do that. Do you think we could fill in the remaining? Let's fill in the remaining bits in that, and let's be like pretty quick about it. If cosine becomes negative, what should secant do? Become negative, because it's just 1 over cosine. Sine becomes negative, what should cosecant do? Also become negative? What should cotangent do? Stay the same, because it'll be cosine divided by sine. If you make both the denominator and the numerator negative, the negatives cancel. Maybe I'll write that. Cotangent of pi plus theta, that'll be cosine pi plus theta over sine pi plus theta. Negative cosine theta divided by negative sine theta. Oh yeah, that's just cotangent. All right. So, folks, feeling pretty good so far? Groovy. So the last thing, well, I have 3 minutes. I think I can make some progress on these last bullet points. So the next one in the list anyway is pi over 2 minus theta. To think about pi over 2 minus theta, I'm not going to use the unit circle this time. Instead, I'm going to draw a right triangle. Because pi over 2 is an angle you see in a right triangle. It's a right angle. So I can use a right triangle to get something. So here's a right angle. An angle of pi over 2. Here's an angle of theta. Here is an unknown angle. Do I have enough information that I could determine that unknown angle? Yeah. In fact, what is that unknown angle? Oh, I guess, like, how would I determine that unknown angle? What do the angles inside of a triangle add up to? Yeah, 180 degrees if you like degrees, but everything today is in radians, so pi radians. So that means theta plus pi over 2 plus unknown angle have to add up to pi. Could I solve that for question mark? Yeah. In fact, how many of you have already solved that for question mark? What'd you get? Pi over 2 minus theta. So if you don't know what theta is, you have no hope of knowing what question mark is. Best you can do is something in terms of question mark. So subtract the pi over 2 to the other side. That leaves you with pi minus pi over 2, also known as pi over 2. Subtract theta to the other side, minus theta. So this missing angle is pi over 2 minus theta. And I'm pretty close to what time, so I don't think I'm going to write much more. Maybe I'll write this. That top right angle is pi over 2 minus theta. So, if I label the hypotenuse as the hypotenuse, then what's the cosine of theta using that triangle? X over the hypotenuse. What's the sine of pi over 2 minus theta using the same triangle? Also x over hypotenuse? Ooh, they're the same. That's what we'll start with next time. Use this triangle to fill in these. And as a reminder, I won't be here on Monday, but there will still be some content. There will be a recorded lecture posted already, and there might be a little bit more posted depending on how far I make it tomorrow.
Thank you.
Have a good day. Ooh, everyone should continue packing and leaving. It is that time.